students. Hi, we meet again. Okay, I hope you can hear me. Please give me a comment whether you're able to hear me loud and clear before I continue lesson. Okay, please type in the chat box, right, whether you can hear me. Okay, today we're going to continue with another lesson, which is we are going to start chapter 5. Okay, so this is thermochemistry. Okay, right, girls. Hi, Stella, Jia Dong, RK, Hui En. Yes, can hear. Okay, good. All right, L. All right, all right. Let's start with this lesson now. Thermochemistry. So, what is the meaning of thermochemistry? So this is actually one branch of chemistry. If you go to Form 4 chemistry, you will learn this as well. Form 4, or I can't remember Form 4 or Form 5 because of new syllabus. So you will be able to learn more about this. So this lesson in Form 3 is an introduction. So you have a little bit of knowledge before you go to Form 4. Now, what is the meaning of thermo? So this word is actually a combination of two words. You have this word thermo, all right, and you have this word chemistry. Okay, thermo actually comes from the word thermal. Thermal actually means heat. Okay, so this is heat. So it has to do with heat, all right? So a thermochemistry is a branch of chemistry which deals with a chemical reaction which either produces heat or absorbs heat. So release heat or absorb heat. So actually either there are only two only. Either whether the chemical reaction will produce heat, actually it will make it warm, or you can feel that it's hot, then it will produce heat. And or the other way is actually can absorb heat from the outside. So in other words, the heat will be absorbed into the substance itself. So this is something to do with heat lah. All right. Chemistry is chemical reaction. Okay, reaction between substance A and substance B. Okay, this is whatever is the reaction we're talking about. We learn it in chemistry. So in Huayu, we call it as 化学. 化学 is chemistry. Okay, so in this chapter, we're going to learn all about thermochemistry. This is not a long chapter. We can finish quite soon. Okay, so here now we look at, in terms of thermochemistry, there are actually two groups. Reactions can be divided into two, whether they are endothermic or exothermic. Okay, let's look at this example first. Now, just now remember we learned in chapter 4 just now about the reactions of metals. Some metals are very reactive and some are not reactive, right? Now, there's some metals which are so reactive that we cannot even do any experiment with it. Sometimes it's very dangerous. If it comes into contact with water or oxygen, it will explode. Okay, so one example which we still can do, but it's quite spectacular to see, is actually sodium. We have this in the lab, all right, or in the chemistry lab. We can actually show it to you if we come back to school, which you don't know when. So this sodium, as you know, that is the second in the order, right? First is potassium. The second metal is sodium. So this is considered quite reactive. So when sodium, these reactive metals, some of them cannot come into contact with oxygen or water. Now this example, if we take a piece of sodium, it's actually a metal, but it's a very soft metal. It is so soft that you can cut it with a knife. You can cut it with a knife just like butter, okay? You can cut it with a knife. And this sodium is so reactive that you cannot keep in normal condition. That means you cannot keep it like you keep other things. You just put it in the air or keep it in a bottle. It is so reactive that we do not want it to come into contact with water. So we actually have to put in a container or a bottle filled with oil, or we call it paraffin. So it has to be immersed in oil. So all these examples of reactive metals like sodium, potassium, calcium, we cannot leave it in a bottle and let it react with the air. So it has to be oil here. So normally we use paraffin. Paraffin is kind of a oil, okay? Paraffin, double F, I think. All right. Paraffin, we call it wax, okay? Oil or wax, okay? Oil. I think paraffin oil. Yeah, paraffin oil, double. Paraffin oil. It's not wax, wax is solid. So paraffin oil will be able to make sure you have a coating of oil here, so your sodium does not react with oxygen or water. We call it, because water moisture is in the air. So once you react, you see what happens? We can do this experiment. You take a piece of sodium, we put into a beaker of water, and it's going to, wow, it's very spectacular. It can be done, and it's actually quite safe lah, but we must do it in the open. We don't do it in a closed environment. We do it in the field, all right? And we just put a piece of sodium, and then it will actually become like this. It will sort of like melt, you know. So first of all, the piece will not sink lah. It's going to be on top, and it's going to roll around. It'll be rolling around and around the water here until it becomes a small little ball, and then you're going to get this kind of fire, all right? Sometimes sizzle, sizzle. You get a sizzling sound. You get, you might even see fire, and then it will become smaller and smaller and smaller until it totally reacted, all finished already, dissolved already, more or less like dissolved lah. Okay, then this is sodium. So when you see this, when you see got fire, you hear got sound like a small explosion. Okay, you can see that there is heat release. Okay, you see the heat, isn't it? Because you see the fire. When you see something that's burning, it's actually producing heat. So this kind of reaction, which produces heat, is known as exothermic reaction. EXO has a special meaning. EXO, not the EXO, the Korean group, the singer, the boy band. EXO actually means outside. So it produces heat and gives it outside. That means it releases. Okay, so this is word EXO. It is a prefix in using Greek word, which means outside. And the opposite, all right, which means endo, is endo. It means inside. So that means it absorbs. So endo is absorbing heat energy. Exo is releasing heat energy. So first of all, you need to know these two terms. Okay, now look here. In chemistry, thermochemistry, we have this word exothermic reaction. Got two groups. All right, you need to remember this. So it's a reaction that releases heat to the surrounding. That means in the beginning, the substance will have more energy inside it. This is reactant. Reactant is a substance that haven't taken part in the reaction. So it has more energy inside. And then when the reaction happens, you see what happens? It will produce the energy. It releases the energy. It already removed the energy out. So that means the product will have less energy because the energy is already given out. So you give out already, you means you have less, correct or not? Okay, so the temperature of the surrounding will increase because the temperature, the surrounding, because you give out the heat. So that means the surrounding, the temperature will become hotter, okay, because you're giving out the heat. So, okay, for example, I have a substance, let's say A plus B, right? Chemical A plus chemical B, right? Then it is, after mixing the two things together, it will produce heat. That means the surrounding will be warmer. If you put your hand, right? If you put your hand there, I don't know how to draw a hand, right? If you put your hand here and you touch it, right? You touch it, you feel that the heat will be taken by your hand. The heat comes to your hand, and then your hand receives heat. So when your hand receives heat, that's why it feels hot. Because the heat comes from the substance there. So the heat comes from the substance, it goes into your hand gets more heat. When your hand gets more heat, you feel it's warm. Okay, you feel that substance is warm. So you see the energy level, right? Beginning has got more energy. Then after that, it releases, so it will get less energy at the end of the reaction. Okay, so that's exo, right? Exothermic. Now let's look at endothermic. Endothermic means it's a reaction that absorbs heat from the surrounding. Absorb heat, right? Absorb heat, that means in the beginning, it will have less heat. Okay, let's say, for example, sorry, I changed this one. Let's say I have a chemical C plus D, all right? Two types of liquid. And then after mixing it, all right, the heat energies come in from the outside. It's taking in energy from the outside. Okay, so it's taking in energy from the outside. So what happens is the temperature of the surrounding will decrease. This is the environment. It take in the energy, take in the heat. So that means in the beginning, it must have less heat. Correct? Less heat because it hasn't taken in the heat yet. After that, when it absorb the heat, the energy of the product should be more. Because it already taken heat. Okay? Now for this, when you touch it, it feels cold. Okay, it feels cold. For here, you can understand just now it feels hot, right? Now, I'm going to explain later why it feels cold. Okay, so just a very simple way of finding out whether it's endothermic, exothermic is by using your hand actually, if you can touch it lah. But of course, I'm not telling you to touch all the reaction. Certain reactions you cannot touch. For example, the thing is burning, heating, and fire, right? You cannot be touching with your hand. It's going to burn your hand, correct? So it's not everything that you can touch. But what I'm telling you is a very simple way of knowing whether it's endothermic or exothermic is by, if you can touch, you can touch it. If it feels hot to your hand, that means it is exothermic reaction. If it feels cold to your hand, all right, if you touch it, it feels colder, it will be endothermic reaction. It's a general way lah, but it doesn't apply for all. Means you cannot touch everything. That's what I mean. All right, you can. This principle can apply for everything. It means that when it release heat, all right, when endothermic is going to absorb heat, when exothermic is going to release heat. Okay, so this is a law. All right, this is a rule. So let's look at other things. Let's carry on. Now, how do we know? Okay, how do we know? For example, how do we know it's endothermic, exothermic? So a very simple way is, right? What is an easy way to find out? So like I mentioned, you just need to touch it. Okay, now when you touch it, this is the exothermic reaction. Is that if it is an exothermic reaction, look at the word exo, your hand will feel hot. So I'm going to explain again why your hand feels hot. The reason is because it is after mixing A and B together, this chemical thing, the two chemical substances mixed already, it's going to produce more heat. So this heat is going to be released. It's going to release the heat out. And if your hand is touching it, the heat will come to your hand. So your hand is going to get the heat. So when your hand receives the heat, you will feel that it's hot because it's taking the heat from here. Okay, the heat is going to your hand. Your hand is going to take the heat. You can feel the heat there, right? You're going to feel because the heat is coming to your hand. Your hand receives the heat. So it's going to be warmer. You can feel it's warmer. Now, when it comes to endothermic reaction, okay, let's say you have another reaction. Why does endothermic reaction make your hand feel cold? Okay, so a lot of students are not able to understand this. So I'm trying to explain to you now. For endothermic, as a general rule, you will find that your hand will feel cooler or cold. It feels cold. The reaction feels cold. Now, why? Okay, same reason is, now just now we mentioned endothermic means what? The reaction release or absorb heat. Okay, if you look at this here, absorb heat or release heat. Absorb heat or release heat. Okay, look here. Endo is absorbs heat. Exo is release heat. So absorbs heat, right? Okay, if I may see if you've got any answer here. I haven't, but you've got attendance there. Okay, so it's going to absorb heat. So absorb heat means from where? Where is it going to absorb the heat from? You absorb the heat from everywhere. Anything it touches and the environment. So it touches the air. So the environment, the air, the heat will be taken in. So if it's touching your hand will also donate heat to the thing. It's also drawing heat from your hand. It's also taking heat from your hand, Whatever it touches, if it touches the air, that means you're taking from the environment, from the air. If it's touching your hand, okay, imagine touching, I couldn't put it touching, okay? This is actually touching, The two hands here are touching the chemical there, the conical flask. So if it's touching, that means the heat from your hand is taken by the chemical. Okay, it goes inside. So is your hand losing heat or getting more heat? Is your hand losing heat now? Is your hand losing heat? Okay, is your hand losing heat or your hand absorbing heat? We're talking about your hand. Is your hand absorbing heat or losing heat? Let me check or something. Someone has written something here. Absorb heat from the surrounding temperature and the hand. Yes, you're right. So here I can give you a very simple example, right? If you're touching any, it would, whatever touches it, it will take in heat. So if your hand is touching it, your hand is giving heat. Yeah, your hand is losing heat, correct. Your hand is losing heat. So when you're losing heat, will you feel warmer or cooler? Let me ask you this question. If you're losing heat, you're losing heat. That means you're releasing heat. Not the thing release heat. No, you are releasing heat to the thing. So are you going to feel hotter or cooler when you lose the heat? When you lose the heat, are you going to feel hotter or cooler? You're losing heat. You're losing heat. You are going to feel cooler. Yes, that's why your hand will feel cold, and the thing will feel cold to your hand. When you touch it, you feel the beaker is like ice water. There's certain reactions, it's going to feel like ice water, So it's very fun to do this experiment. So when we go back to class, we went to school, I'm definitely going to make you do this experiment. It's very fun because sometimes when you have going to have one chemical, when you mix with the water, it's going to feel like ice water. Wow, fantastic, right? It's going to feel so cold, ice water. So therefore, right, it's very fun to do. And some more, we need this experiment for one of your experiment wajib. Remember, we have done 5. This is number 6. Okay, so in this holiday, the 2 weeks holiday, I need you to write out one more of this experiment report. Okay, experiment report. Make sure you have diagrams, so you can follow the textbook or the workbook. Okay, so I'm going to give you some readings, because without the reading, you cannot do the experiment, correct? You cannot write the report. Okay, so now you can use your hand, right, in order to feel. You use your hand to feel, use hand. But hand is not a very reliable way of testing everything, right? What is a more reliable way? What is a suitable device to be used to determine whether the reaction is endothermic or exothermic? Your hand is not reliable, because it's, human, So you want to have a device. What is the device? Please answer this one in your comment. To determine whether the reaction is endothermic or exothermic. Like I mentioned just now, your hand cannot touch everything. You can't put your hand into the fire. Right, to know the reaction, when the reaction produces fire or heat, flame, you cannot put your hand there to feel that's hot. So what can you use instead of your hand? What's a suitable device? I'm sure you know this answer. Yes, good. Thermometer. Thermometer is very reliable because it's consistent. All right, it works. Unless it's spoiled, right? It works, and you can use it to measure any increase in temperature or decrease in temperature. So when the temperature increases, it means that the reaction must be producing heat. That means originally it's not so hot. Once you add the two things together, it becomes hotter. So when it becomes hotter, that means it's releasing heat. Okay? And then on the other hand, if you have put a thermometer there, all right? Your thermometer, okay, let's say this is a chemical reaction. You put a thermometer there. Let's say initially the reading is 28 degrees Celsius, okay? And then after that, right, when you add in together, you mix it up, and the chemical and the temperature rises to 40 degrees Celsius. That means it is producing heat, okay? And the same thing if, let's say, originally your temperature, right, is 28, right? Before you add your substance, your A is there, you add your B there, you add another thing inside. Then when you mix it around, after that you can find that the temperature, the reading actually goes down. Let's say it goes to 18 degrees Celsius. Then when you feel it with your hand, you can feel that it's cold or cooler. So this one means it is absorbing heat. This is absorbing heat. Okay, this one is releasing heat. Okay, so that from here you know which is endo, which is exo already. All right, so it is for you use a thermometer. When a heat is released, when you can feel that the temperature rises. So how do you know whether it is endothermic, exothermic? Look at the temperature change. If temperature rises, that means it's an exothermic reaction. And then when there is a drop in the reading, that means the temperature decreases. It shows the heat is absorbed from the surrounding. it is an endothermic reaction. Okay, so the very simple understanding here. So I'm going to go through the experiment so that you can do your report. All right, now there are 4 experiments to be done here. This is to know what is the similarities and differences between endothermic exothermic reaction. So you need to actually, hypothesis is answering the problem statement. Okay, so this is to answer here lah. Actually, not similarities and differences. I would like you to change this. Okay, what are endothermic and exothermic? What is the definition? Okay, what is the definition? What is the meaning of endothermic and exothermic reaction? Okay, so because this hypothesis doesn't answer the problem statement, that's why I want to change it. For usually hypothesis will try to answer the problem statement. So if it doesn't match, that means something is wrong somewhere. Okay, so problem statement is what is the meaning of endothermic exothermic reactions? So exothermic reaction is a chemical reaction which releases heat into the surrounding, while endothermic reaction is a chemical reaction which absorbs heat from surrounding. Okay, it doesn't answer the similarity and differences, so I would change it because it should match. Your problem statement should be able to be answered by your hypothesis. Okay, so here are all these substances. You can read later on your own. So I want to explain to you. There are 4 experiments here. The experiment is like this. Okay, you can read this later. Right. First of all, let's go through first. You add pour water first. So one of your substance here is water, right, into a polystyrene cup, and leave it for 2 minutes. Now, why you need to leave it for 2 minutes? Because you want the temperature to be consistent with your room temperature. It takes time for the temperature to settle down. Okay, maybe this water is stored in a container, so it could be warmer than your temperature in the air. So you must let it settle down first, wait for 2 minutes, and then only you take the temperature. You call it initial temperature. It is more reliable. So always leave it first to make sure that it come to what we call a thermodynamic, we call it equilibrium, thermal equilibrium. That means it's same, it will equate, it will be the equal temperature with the environment. So then only you take your initial. So leave it for 2 minutes before you take your initial temperature. So this is your initial temperature. That means before reaction. You haven't added anything yet. There's no reaction yet. Okay. So this is called the initial temperature reading. All right. Now, secondly, you're going to put in 2 spatulas of sodium hydroxide. Sodium hydroxide is solid form. This is an alkaline. This is a alkaline. Hydroxide are all alkaline. So it is like pellets, white color one. It's solid. So you add in 1 spatula, and you know 2 spatula. It is going to be too strong. You add 1 spatula, and then you gently mix the mixture until all of it dissolves in the water. All right. After that, again, you put your thermometer inside there. In fact, you can leave it there all the time, and you make sure you follow the reading, see whether it goes up or not. If it goes up, you see it go to the maximum. If it goes up, you must see the maximum. If it goes down, that means it is getting cooler, right? If it goes down, you must follow until you go to the minimum. Okay, because after minimum, it may go up again. And then after maximum, it may come down again. So you must take the maximum value or the minimum value. Okay, if it goes up, that means you must follow until you go up to maximum. Then you take the one, because afterwards, it's going to drop. All right, it will not maintain there, maximum. So when it's minimum, it will go all the way down until the coolest temperature. Then after it may go up again because it's going to achieve equilibrium with the environment, with the room temperature. So when it goes to the minimum, you take the temperature there. Okay, so you must record the minimum or maximum temperature. That's the first one. Now that's the first experiment here. This is one. You just mix your sodium hydroxide with water. Okay, so this is your reaction, the first one. Experiment 1, 2, 3, 4. Yeah, 4. Okay, I'm giving you the values here because without the values, you cannot determine whether they're endothermic, exothermic. And because you're not doing the experiment in the lab, you're not doing it in the lab, right? We got no chance to go back to school, right? So I have to give you the reading so that you can do your report. Okay, second one, you do the same thing. You have a beaker, polystyrene cup. Now, why do we use polystyrene cup? Polystyrene cup is used because polystyrene is a very good what? It can able to keep your heat. Okay, it's a good insulator of heat. Polystyrene cup, the white color thing that you always come in the packaging one, that you can easily break one. Okay, when you buy something new, it comes like TV, it comes with the packaging, the foam. We call it the foam, not really foam lah. It is called polystyrene. So it is can preserve heat. If it's hot, it will keep the heat longer. If it's cold, it will also make sure the heat doesn't come in. So it will preserve the heat, the cold longer. So it is a good insulator of heat. Okay, so if you don't have that, it's okay. You can use a normal beaker. Okay, but the insulation not so good lah. Okay, second one, you put ammonium chloride salt. Same thing, you put water first, you take the initial temperature, leave it for 2 minutes. After that, you mix in 2 spatula of ammonium chloride. You mix it and take the maximum or minimum temperature. So I'm giving you here is 15. All right, so it's going to go down. The temperature goes down. All right, for this one, the temperature goes up. Okay, the third one. Now, third one here, just now you have already used, you've already made your sodium hydroxide, isn't it? Here, for the first experiment is sodium hydroxide. You use back this liquid for your third experiment. Here, hydrochloric acid. Now you add acid with this, just now the solution from number 1, but you make it cool down first. All right, this solution just now that you made, you make it cool down first to room temperature. Then now you add acid into it. Okay, you add acid. First of all, take the initial first. Initial temperature is 30. After you add your hydrochloric acid into this thing, it becomes 37. Okay, so I'm giving you the figure. All right, I won't tell you what kind of reaction. This is your job. You need to answer. Okay, the type of reaction here. Okay, and then lastly, right, hydrochloric acid. The next one, you take acid and you use sodium hydrogen carbonate. Now, this is a chemical name for actually baking soda. Baking soda, you use it for baking your cakes or your whatever lah. Okay, sometimes you use it for donuts also. Baking soda will make the thing rise. The flour will rise. So this is sodium hydrogen carbonate. Another name is sodium. You can jot down so you know if you change the name. Sodium bicarbonate is the same. Sodium hydrogen carbonate is same as sodium bicarbonate. It's actually baking soda, which you can buy from the grocery shop. You can also buy from supermarket. Okay, so you mix these two, mix it into your, of course, you take your temperature of the acid first, leave it for 2 minutes, take your initial temperature, then you mix in your 2 tablespoons, I mean 1 or 2 tablespoons of baking soda, then you mix it around, right, and you record your highest or lowest temperature. You will find, okay, I give you is 25. Okay, now from there, you'll be able to know from the temperature increase or decrease, temperature drop or temperature increase, you will be able to know that whether it is endothermic or exothermic reaction. Okay, so like I mentioned earlier, if you go back to this lesson, I say if the temperature rises, it means it's producing heat. If the temperature drops, it means it is absorbing heat. Okay, so now with this reading I've given you, you should be able to fill up this one. So I'm not going to give you the answer because it's going to be your report. Type of reaction. What type of it? We only have 2 types only. Okay, the 2 types, the name you should know. We only have 2 types only. So then later on, all right, the question should come before conclusion. Always remember when you write a report, the conclusion is the last thing that you write, not the questions after. So from your report that you've given me earlier, some of them you just follow from the textbook, which is not so correct. The conclusion is actually come to the last. Okay, so the questions are, I will discuss all these questions in the Google Classroom. Okay, but first of all, I think this is easy. Number 1, what is the operational definition for release of heat? Okay, release of heat, that means how do you know the heat is released? Operation definition is something that you can observe. When you do the experiment, how do you know there's release of heat? Okay, when this experiment, how do you know the reaction has released heat or not? Because we have something to measure. We have something to measure. This is the key, the clue I'm giving you, something to measure. So when you see what happens, then you know there's release of heat. Okay, then absorption of heat as well. So you answer this one. Okay, so what happens when the temperature shown on the thermometer is at maximum or minimum? Okay, now when the temperature shown is at maximum or minimum, like I said just now, you go up to the top, to the highest, all right, or you go down right to the lowest. Okay, what happens is actually it will. Okay, I won't give you answer first. Okay, I think I want you to try and find out this answer, because if I give you everything, that means everybody will get it all right. I'm not testing anything. Okay, I want you to try to find out the answer first. Okay, state the criteria used to classify. What is the criteria? How do you know it's exothermic or endothermic? How do you know it's exothermic or endothermic? Okay, what is the criteria? Whether it will release heat or absorb heat. I'm giving you the clue already. Okay, list the exothermic reaction. So from here, list from here. There are 4 here. Which are the endothermic reaction? You must write reaction between sodium hydroxide and water, or reaction between ammonium chloride, salt and water. So you write this name. Classify them. Which is endothermic, which is exothermic. Okay. And number 6, this is a K-Bite question. How can the accuracy of the maximum or minimum temperature be increased? How do you want to make sure your experiment is more accurate? Means when it goes up to the maximum, you don't want the heat to go out. You want to preserve the heat. I'm giving you a clue. How you want to make sure the heat doesn't go out. Okay, what kind of apparatus can you use besides using the polystyrene cup? How to increase the accuracy? And if it's a reaction that is cooler, how do you make sure the heat from the outside doesn't come in and make it warmer? That means how do you make sure it's accurate? Okay, think of the things that you can do to make it more accurate. You don't want the heat to escape. Okay, now explain your answer. Right? What do you use and why? Why do you use that method? Okay, so these are a little bit okay, but okay, I can give you further instructions in the what they call the Google Meet later. Okay, now before that, after that, now after this, I want to go through this now. What are the examples in everyday life, in daily life? What are the examples of endothermic and exothermic reaction? So you will see here. Okay, here fireworks display. Now, if it's something that you can see fire, okay, you notice there is light produced or fire produced. Usually, these are the ones which are producing heat. Okay, they produce heat, so they will be considered as exothermic. Okay, and from here, now let's look at the second one. So this is exo, right? Fireworks display is exo. Now, photosynthesis. Okay, photosynthesis, you think of what is photosynthesis first. Photosynthesis is you have this reaction of carbon dioxide and water, right? Carbon dioxide and water, and then it will actually take in sunlight, isn't it? You need sunlight, you need chlorophyll, and then you're going to produce your glucose and oxygen. This is your photosynthesis reaction. All right, so what happens here is the sunlight is being absorbed. The sunlight is absorbed, in order for the what they call the plant to produce food, it has to absorb sunlight, isn't it? Like you notice, you say, always say absorb sunlight, absorb heat, absorb energy from the sun, absorb energy. So you already, from the word, you already know absorb. Absorb means what? It is absorbing the heat. So absorbing the heat is under which one? Endo or exo? Okay, can you put in your chat box here? Photosynthesis is endo or exo? I already give you the keyword there. It says that it has to absorb the sunlight. Yes, I need somebody right down there already. Good. Yeah, photosynthesis is endothermic reaction. Yes, correct. Okay, so I can put this over here. All right, fireworks is combustion. Combustion, you can see, is producing heat, producing energy. So it is exothermic. Okay, next one. Let's look at the cake baking. You have already mixed everything. Your flour, your egg, your whatever, butter and everything, sugar, mix everything, and you put it into the oven, you pop it into the oven, right? In order for it to cook, in order for your batter to become cooked, it has to, you put it in an oven. The oven is producing heat. And what has the cake got to do? Okay, what is the cake doing? I'm not talking about the oven. You're not talking about the oven producing heat. I'm talking about the cake mixture. The cake mixture, is it absorbing heat or is it producing heat? Talking about the cake mixture, not the oven. The cake mixture, in order for it to cook, will it have to absorb heat or does it release heat? Okay, I've got an answer here. It is endothermic. Yes, cake baking is endothermic because it has to absorb heat, then only it can cook. Correct or not? It absorbs heat. So the cake is actually absorbing heat. So it is endo. All right, so you need to know how to classify them. Okay, one more, respiration. Respiration is a process whereby what? Respiration is opposite of photosynthesis. Respiration is this. So you have your glucose, you have oxygen, right? And then it's going to burn, right? It's going to burn, like I said, oxidize inside your cell, which you can't see the fire. It's going to oxidize, and you're going to get carbon dioxide and water. And more importantly, it's producing energy. Don't forget. So here, very clearly, you can see what? It is producing what? Producing energy. So what kind of reaction is it? What kind of reaction is respiration? It's producing energy. Producing energy, many forms of energy. Okay, anyone to answer here? Respiration now. Respiration comes under what? Let me check. Not yet, no reaction, no answer yet, okay. Here, got? Yeah, I see something. Exo, yes, correct, exo. So it's already producing energy, so it is producing heat. All right, so respiration comes under exo. All right, so you need to remember these 4 examples. Of course, I can give you more for you to understand more. Now, if you in Form 2, you will learn this process called neutralization. Neutralization is an acid plus alkali. Okay, you also see one example here. One of this, here's this is one of this. I'm not going to tell you which one. One of this is a neutralization. Neutralization is when you see an acid react with an alkali. This is called neutralization. So acid is no longer acidic when it combines with alkali. Alkali is no longer acidic, it becomes neutral. So that's why I call it, this process is called neutralization. Now neutralization, it produces heat actually. So I'm telling you that. All right. So if it produces heat, so this is actually an exothermic reaction. You produce heat. You can feel it warmer. When you do the experiment, you'll feel it warmer. Okay, next one. Evaporation. Okay, evaporation. Evaporation is the process whereby what? Your liquid, this is the molecule in liquid form. Liquid changes to gas. Okay, changes to gas. The molecules will be further away. So in order for it to be further away, okay, ask yourself this question. Does it have to move more or move less? Does it have to, is the movement here or the vibration or the movement here has to be more vigorous or less vigorous? Because it has to push away from each other. So when this liquid forms gas, actually they are moving further and further. They are pushing away until they can overcome the energy between the 2 atoms or the 2 molecules here. So they move away further and they become gas form. So that means it has to what? In order for them to get energy, to move faster, it has to move faster now. It has to what? In order to get energy, it has to absorb heat. Okay, so it has to absorb heat, then only you can move faster. If you don't have enough energy, how is it going to move faster? Okay, you must get energy absorbed. Then you move faster and faster and faster until they can push away so strongly that they're able to move away or overcome the attraction, the force between the 2 molecules. Then it comes further. Then it will only become the gas. So it's a what kind of reaction? Yes, vibration has to be more vigorous. So in order to be more vigorous, you need to get more energy. So it has to absorb, correct? The absorb. So your evaporation is absorbing heat. So it is an endothermic. Okay. So so in this sense, what about melting? Melting is from what? Solid to liquid, right? So melting is solid. So I'm going to draw ice now. Melting ice. This is solid. Everything is all together. Now it wants to become what? This is solid. It wants to become liquid. Liquid means like this, further away. So when it's further away, that means this one, the molecules here have to move what? More or less. Is the movement need to be more vigorous or not? It has to move what? Faster or slower? It has to move again. Okay, it has to move faster, right? Yes, it has to move faster because in order to move faster, it has to produce energy. Absorb energy. No energy, how to move faster. All right. So absorb energy. So it's going to push and push and push and push until it becomes further away. So it already formed liquid. So this one also absorbs heat. Okay. So melting ice is absorbing heat. So it is endothermic. So a lot of things can make sense. Okay. If you look at it one by one. So endothermic. What about combustion? Combustion is burning. Okay, burning. As I give you the keyword burning, you see the heat, you see the fire. So it is, you stand near the fire. Do you feel hot? You stand near the fire. Why do you feel hot when you stand near the fire? When the wood is being burned, it's because it's combustion. And you feel it's hot because what? It is producing heat, right? So it's what? Okay, melting is endothermic, correct? Yeah. So if combustion, it will be, you stand near the fire, think of it, you are absorbing the heat, right? So it is producing, you're talking the fire is producing heat now. The fire is making heat. So combustion is exothermic. And in fact, any combustion is exothermic. Okay, now dissolving acid in water. Okay, dissolving acid in water. This one is endothermic. Okay, this one is endothermic. Okay, so of course you will need to do experiment in order to answer why, that is very difficult to explain here. Okay, corrosion of metal. Corrosion of metal is actually also, this is dissolving. Dissolving is exo. Sorry, I put in wrong place. Dissolving is acid in water is exothermic. All right, corrosion of metal is also exothermic. Okay, dissolved detergent in water is also exothermic. Okay, so quite a number of reactions are exothermic. Okay, so these are the examples that I want to give you. So if you talk about condensation, let me give you another example. Condensation. Condensation is when you have the opposite. You have, let's say, water vapor in the form of gas. This is gas. Let's see, I must draw further away. Gas. I must draw further away. So this is gas. Gas to become, let's say, liquid. Now this is condensation. To become liquid, that means it's got to further nearer. So does it have to absorb heat or does it have to produce heat? I wait for your comment. Okay, in the meantime, I just draw. So you see, these are movements. The molecules are moving and moving, vibrating, right? In gaseous form, they are very free. They are moving a lot, very fast, moving very fast. And then now they want to come nearer. When they want to come nearer, do they need to absorb more heat, which make them move faster? Or do they need to release the heat to make them slower? So is it absorbing or releasing heat when they want to become come nearer, when they want to become liquid, when they want to come nearer? So release or absorb? Okay. Yes, release heat. Good, correct. Because if you absorb some more heat, it will even go faster. You even go faster, but it cannot come back together, right? You have to release heat. When it releases heat, that means it will move slower and slower and slower until they come nearer. So when they come nearer, they will form liquid. So this is condensation. So condensation is releasing heat. Okay, condensation is releasing heat. So it comes under exothermic. Understand? All right, so I'm giving you examples. So what you need to remember in this experiment, in this chapter, right? I just give you a summary. Everything I've done in one chapter already, one lesson. Number one is definition. What is the definition of endothermic and exothermic? So you need to remember this one. Okay, where is it? Here. is a reaction that releases heat for exothermic, and endothermic is a reaction that absorbs heat. Okay, this is the basic thing you need to remember. And how to measure it? You need to use thermometer. And thermometer, how to use a thermometer? You see when the temperature rises, like here, initial temperature is lower, then the final temperature is higher, it means it's absorbing heat. Okay, just jot this down. I remember this is a diagram that makes you remember. If it's lower in the beginning, afterwards it's higher, that means it's releasing heat. It is an exo. Okay, I'm gonna write here after it helps you with your report. Okay, then this one, if on the other hand, your initial is like this, 28, right? And then after the reaction, it goes lower. It goes lower, actually, it is absorbing heat from the environment. The environment becomes cold, not the environment becomes colder. So it is releasing heat. Releasing heat is a endothermic reaction. Okay, that's the definition. The two things. Okay, after that, you need to remember some examples. These 4 experiments you need to remember. What are endo, what are exo, which are endo, which are exo. So these 4 things. Dissolving sodium hydroxide in water, number 1. Dissolving ammonium chloride salt in water. Number 3, reaction between hydrochloric acid and sodium hydroxide solution. Number 4, hydrochloric acid and sodium hydrogen carbonate, which is baking soda. 4. You need to remember this 4 experiment. Okay. And lastly, examples. Other examples of endothermic and exothermic reaction. Okay. So I will stop here because we need to go back to Google Meet. Okay. We need to go back to Google Meet after this. So I will stop here and then we will have further discussion from there. All right. I'll discuss with the thermal equilibrium. Okay. For your report here. Okay, so I will see you afterwards. Okay, bye-bye, girls. Yeah, condensation is exothermic. Yeah, correct. Okay, so I'll see you afterwards. Okay, bye-bye. Bye-bye, all those out there. Okay. Thank you for joining my class, those who are from outside my school. Okay, bye-bye.